welcome to Science. Information about us. Channel name Education the Key to Success. Chapter 11 Force and Pressure. Education the Key to Success.
Topics to be covered.
Force, a push or pull. Forces are due to interaction. Exploring forces, where we will see, can force change the state of motion? Can force change the shape of an object?
We also look at contact forces, muscular and friction, as well as non-contact, that includes magnetic, electrostatic and gravitational force.
We will end with pressure exerted by liquids and gases, and atmospheric pressure.
So let's start. What is force?
Force is a push or pull. It's applied externally. A force, a push or pull.
So actions, daily actions like picking a book, opening the door, shutting the cupboard, kicking a ball and so on, also need force in some or the other form. In science, a push or pull on an object is called force, irrespective of the size and irrespective of the amount of force.
Forces are due to an interaction. How can you say that?
Well, you must have played arm wrestling or kicked a football or hooped a basketball in school. In that, all of those situations, force is applied. For example, if two students are playing arm wrestling, the person who applies greater force wins.
Try remembering this from class 6th. When an external force is added to an object, the object comes in motion. Or rather, let's say, when sufficient force is applied to any object, the object comes in motion.
Or if an object is in motion, it can also come to a halt.
Right.
So let's explore forces. If you are trying to push a heavy box with your friend, how will you push it? Even without having any knowledge of physics, intuitively, both friends will come on one direction and push it. Will you ever ask your friend to push it from one side while you push it from the other?
Oh my god, that would be a really funny situation.
Indeed. So if your friend is going to stand on the other side, one of you will have to push and the other one will have to pull.
Right. Because if you push on both the sides, your force will minus and it will come to zero if it's equal, or the person who's applying more force will manage to shift the box or the object to another side.
Can force change the state of motion?
Yes, it can. The way you apply force can change the way the object moves. For example, if you apply force on a ball from below, it will go up in the air. But in this, applying force doesn't mean pushing like it did in other examples. It means via a tap. Okay?
So if you apply force to the sides, the ball will go in the opposite side. That is the intended direction of the kick. In the same manner, how you apply force also changes the speed of an object. So what do you think about the speed of the tire?
It's going quite fast, I think.
Indeed, and I think it's related to the force applied via the stick.
Yes. And how does the stick apply force?
Through the boy's arm. Can force change the object? Can change the shape of an object as well?
For this slide, let's take the example of a rubber band. So, if you take a rubber band or an elastic, which is used in most of your clothings, for example, a skirt or a pant, you can see that it elongates a bit, it stretches a bit to give you some flexibility. And if you hang a rubber on a hook and you apply force from below, you will see that it actually elongates, which is the same thing as an elastic. So we can say with this example that force can change the shape of an object temporarily or permanently. If you take the example of cotton, you can apply force on it and change its shape. How do you do that?
Well, if you take raw cotton and you make fine strands of it interwoven, that's what creates a thread.
And even if you don't create a thread, another thing that can change cotton's shape is trying to elongate it. Of course, it will not get stretched like a rubber band or an elastic, but it will expand, which will result in the changing of its shape.
Contact forces. Why are these people shaking hands?
This is because they are having contact with each other. But the present situation of coronavirus doesn't allow us to do that. But still, this might be an earlier picture.
Indeed. So we look at muscular force and frictional force.
Muscular force. So, if you try to lift a book or carry even a small thing such as a pen in your hand, you can't do it without touching it. Why? Because you need the force of your muscles to pick or carry anything or do anything.
So essentially, whether it is a light load or a heavy load, you are using some part of the muscles. If you're carrying a heavy load, maybe use your forearms, shoulders, biceps. If you are walking, you are using your thighs or calf muscles for walking. And if you are carrying a pen, maybe it's just between the tip of your fingers.
Friction. We will have an entire topic about friction, so you don't need to worry about getting too much deep into this.
Indeed, but it's important to understand that the frictional force is always in the opposite direction of the pushing force.
Yes. So when you kick a ball, it goes on for a while and then it slows down and gradually stops. So why does it stop? That is because friction prevents it from rolling more, and that friction prevents it as the force applied is not enough at that point of time.
So do you think in daily life friction is important?
Yes, it is very important. You cannot walk if there's no friction. You will keep slipping actually.
Indeed, and can you imagine what will happen to the thousands of vehicles, trains and aeroplanes?
They will not be able to exist in this world.
Indeed.
Non-contact forces.
Magnetic, electrostatic and gravitational. We are seated right now. Should we thank gravitational force?
Yes, we should. Magnetic forces. We are sure that you have observed some magnets cling together as you bring them together, but sometimes they may repel, but we are not studying about that in this chapter. But even if you leave your hands by keeping the magnets a bit close to each other, not like poles of course, they will still come together without contact. This is therefore included in non-contact forces.
And what's an electrostatic force?
When two charged particles try to come in contact, or even one charged particle, it like this shown in the picture, where a comb is actually charged because you've rubbed it in your hair, and the pieces of paper are sticking to it, so that is called as electrostatic force.
Should we try an activity? Let's take a straw and cut it into two pieces. They should be equal, and you suspend one part with a rope. What happens next?
We do make sure that the other end of the straw does not touch the straw. Now rub the end of the suspended straw also. Now observe. we will see that the straws will attract to each other, but when only one straw is rubbed with a sheet of paper, but they will repel if both the sides are rubbed by a sheet of paper. Interesting, right?
Indeed.
Gravitational force. Who do you see in this picture here?
Of course, it's Mr. Newton.
Yes, he is the one who discovered gravitational force. And how did he discover it?
Well, I think the great scientist was sitting under a tree, and we all know that the apple fell down.
So he was wondering, why did the apple go come down and fall down? Why didn't it go up into the air?
That's because the apple had no wings. Well, gravity was acting on it, wasn't it?
Yes. How does it help us to eat? It does so by keeping the food that we eat on the plate and not letting it fly in the air. What will happen if gravity was not there?
Indeed, imagine the water of rivers flowing upwards or in some different direction or in a direction as determined by the wind or the breeze. And every single object in this universe, small or large, exerts a force on every other object, and the laws of gravity apply.
But you must keep in mind that even if you have gravitational force or you exert gravitational force, you will not attract other objects towards you because the Earth's gravitational force is a lot.
Indeed, and it's uniform.
Yes. Now we come to the second topic, which is pressure.
Let's look at pressure exerted by liquids and gases. If you take a bottle and make 2 holes in it and pour water, which will come out with the same pressure.
Another example can be, take a bottle, fix a rod at the bottom, cover it with a balloon, fill water in it, the balloon will bulge, as you can see in this picture. So why is this happening? This is happening because the inner walls of the rubber of the balloon are exerting pressure, which is actually exerted by the water, and water is a liquid.
Yeah. Atmosphere. Quite a few layers our atmosphere has.
Yes. For an introduction on this topic, let's recall what atmosphere exactly was.
An envelope of gases that surrounds the Earth or any other planet. The atmospheric air extends up to many hundreds of kilometers. Now let's understand what atmospheric pressure is.
The pressure exerted by atmosphere is called atmospheric pressure, as its name suggests. Let's see how large or small the atmospheric pressure is.
Atmospheric pressure is the weight of air in a column of unit area. To understand it better, try taking a rubber sucker and place it on a surface and try to pull it. It will be hard to do so.
To take it out, you need to have more pressure than the atmospheric pressure that is applied on the rubber sucker. If you try to take a vacuum and if you try to take all the air out of that rubber sucker, it will result in lots of atmospheric pressure. Actually, all the atmospheric pressure on it, because there will be no air inside to exert pressure.
Indeed, that would be a very strong bond, right?
Yes, and no human on earth, the strongest or the weakest, will not be able to pull it out.
So you'll typically need to slide it, and when you slide it, air gets in, and that's how the rubber sucker comes out.
Yes. A fun fact, there is about 300 pounds of atmospheric pressure on our hand.
My God, I'm really started to feel heavy.
You can always ask your doubts to us through the comments section. But one thing I would like to tell you is that it is actually a fun fact and some more information. There, as you saw in this rubber sucker, let's go to the previous slide. Yes, so as you saw in this rubber sucker, actually there was an experiment conducted with Madisburg hemisphere, I think it's called, and vacuum was created in it, air was removed, and horses were pulling it from both the sides. I think 6 to 7 horses at least from each side.
Were they able to separate them?
No, that was only and only because atmospheric pressure was getting applied on the.
Oh my goodness. Maybe we should also share a link of that experiment.
Yes, we will make sure to share the link in the eye that is popping up and the description box below.
So don't forget
To like, subscribe and ring the notifications bell so that you don't miss any update. Thank you.
Thank you.